My name is John, and in this presentation we'll be talking about high availability and disaster recovery. So two risks we want to focus on in this presentation are data loss and downtime. Data loss is also referred to as a recovery point objective. So how much data loss can your organization withstand, and how much downtime can you withstand, or a recovery time objective, RTO. These two can disrupt business operations, affect customer trust, and cost your organization valuable time and money. Can your organization tolerate a day's worth of data loss or a day's worth of systems being unavailable? In this presentation, we give you some tools and techniques to avoid these particular risks. So what approaches are there? There's three approaches that we're going to cover in this presentation. The first is backups, so the ability to take a snapshot at a point in time, store it in a secure location, and apply it if there's a failure. High availability, so minimizing single points of failure by maintaining machine redundancy within a data center. And finally, disaster recovery, which is, again, eliminating single points of failure, but at a data center level, so that you have geographically separate environments, primary and standby, in different regions and different areas. And if your primary data center were to go down, you can flip over to your standby data center. So these approaches aren't exclusive of each other, but they're built upon each other to achieve a complete disaster recovery plan. For example, someone that is taking advantage, or an organization that's taking advantage of high availability isn't going to avoid backups. So at minimum, an organization should always be backing up their data and configurations. But on the other end of the spectrum, an organization investing in geographic redundancy, so separate data centers, is also going to likely take advantage of high availability within a data center. And typically the investment costs and the cost to maintain the environments is going to drive an organization or steer an organization towards one approach or another. For example, taking into account the money required to invest in hardware, software, people, and processes. On that theme of people, having the staff knowledgeable enough to execute the plan effectively. And also time. So being able to practice and perfect a disaster recovery plan is really important. So the first approach we're going to talk about is backup and restore. So backups can be considered the easiest way to avoid data loss and downtime. They're often performed hot, meaning there's no downtime on the system when you're taking the backups. And they're often underappreciated. We may take for granted that our phones are backing up our contacts, photos, apps in the cloud. If you have to get a new phone, you can easily download all that information again. There's other ways, there are a number of ways that you can take backups. VM backups, virtual machine backups, or snapshots. File server backups, software backups, such as ones that come with enterprise geodatabase or a database such as Postgres, SQL Server, Oracle, and obviously ArcGIS Enterprise. Within this presentation, we're going to be talking about using the WebGIS DR tool to back up an ArcGIS Enterprise deployment. So the DR tool was introduced at 10.4, and what it does is it backs up all the settings within Portal, Server, and Data Store, all of the portal content, so any of the content available within the portal, any services on any federated server, including the hosting server, and any data within the ArcGIS Data Store. This is relational, and optionally the scene tile cache data. So the time to create these backups is going to be dependent on the size of the ArcGIS Enterprise. It could range from half an hour or more to an hour or more. It does require a Portal for ArcGIS at minimum, so you can't run the DR tool against a standalone server. There are backup utilities available for server outside of the DR tool. So while we talk about what the DR tool does back up, we also have to mention what the DR tool won't back up. So what you or your organization have to be responsible for outside of the DR tool. First is any enterprise geodatabase data or file-based data. This is any data that's used in services published to server. Any traditional cache tiles, so the map service cache tiles, they're simply too large to include within a backup. And any data within the spatial temporal data store or GeoEvent services, these need to be backed up manually, along with your processes to back up your deployment using the DR tool. So the DR tool comes in with the install of Portal within the tools directory of the Portal install. And it'll include a batch file or shell script along with a properties file. The properties file has certain necessary information to know which portal to back up, what credentials to use, where to back up the files, whether you want to include scene caches or not. Once you're backing up the enterprise manually, you can schedule it. So you can schedule it using Windows Task Scheduler or cron tab so that you always have a consistent process to back up your ArcGIS Enterprise deployment. When you're ready to back up or populate the properties file, there's some questions that need to be answered or you need to ask yourself depending on your configuration. For example, where's your content? Is it on the file system? Is it in a bucket in S3? Is it in a container in Azure? So these types of configurations are going to drive what properties need to be populated within the properties file. You can also ask yourself where do you want your backup stored? On the file system or cloud storage. Again, the properties file is going to be updated differently depending on where you want to save this stuff. There are minimum parameters that have to be populated. For example, the portal admin URL is the URL to connect to the portal, credentials for an administrator within the portal. Whether you want to create a full or incremental backup, we'll talk a little bit more about this in the last section within this presentation. And where you want each backup stage, so Portal Server and Data Store will each stage their backups before the DR tool will zip them up. And finally, where to store the backup, whether you want it to be on a file system or in cloud storage. Once you've populated the DR tool properties file, you can run the backup operation to create backups. When you do this, all backups are run concurrently, meaning they all start at the same time and they run in parallel. So while there's no downtime during the export, people can still access content, create content, so forth. There may be some increased CPU usage on the machine as these backups are completed. The syntax to run a backup is to pass in the path to the batch file or properties file, use -E or --export to create a backup, -F or --file, and pass in the WebGIS DR Properties file that's been updated. The restore process runs sequentially. So it'll first restore data store, then it'll restore server, and then it'll restore portal. There is going to be downtime while restoring, so the environment's not going to be available until the restore process is complete. The syntax is very similar. The only difference is instead of -I or -import, instead of -export or -E for exporting, you're going to use -I for importing. All right, so now we're going to transition to high availability. So here's an overview of what we'll talk about. We'll cover what is high availability, what does it mean to be highly available. We'll talk about the ArcGIS Enterprise components that are involved in being highly available, along with the upgrade process for them. I'll briefly touch on other factors to consider when considering high availability. So high availability, by definition, is a system or a series of components that can continuously be operational for a desirable length of time. And it's often measured in being relative to 100% operational or maintaining a certain level of service level agreement or an SLA. And you'll often hear this in reference to how many nines of availability. 99% availability, or 2 nines, 99.9, 3 nines, 99.99, 4 nines, etc. And obviously, shorter downtime costs more. So the machine or the environment that supports only, let's say, 5.26 minutes of downtime per year is far more complex than the system that needs to support only 3.65 days of downtime per year. And the overarching theme about high availability is minimizing single points of failure. So being able to have multiple components with the same role, that if one of those components were to go down, the other machine can take its place. And it's important to keep in mind that the availability of a highly available system depends on the availability of all individual components, processes, and people that make up that architecture. But within this presentation, we're going to be focusing more so on the ArcGIS Enterprise components. So ArcGIS Enterprise is made up of portal, server, and data store. Each of these have the ability to be highly available. Before we get into each of these three components, I want to talk briefly about the load balancing options within ArcGIS Enterprise. So there's two approaches there's two distinct pieces of technology that you'll want to use within, or that you may use within your deployment. The first is the web adapter. The web adapter is it's essentially a reverse proxy. It also can act as a load balancer using basic load balancing algorithms, a round-robin approach. It's provided by Esri, and it can be used along with web tier authentication. So you can use web tier authentication such as IWA within your deployment. And the benefit about including a web adapter within your configuration is that it can detect when machines are joined or unregistered from the sites. For example, if you have two machine service site and you need to scale out horizontally, so add an additional machine to the site, the web adapter is going to be able to detect that change and then send requests to the new machine. What's also going to be included within an architecture is a third-party load balancer. These are not provided by Esri, but they're typically already fault tolerant. You know, the commercial products like F5, they're already going to be highly available in nature. These typically can't detect machine changes within the site, so a load balancer administrator may need to add the machines to the configuration if ones have been added to the site or removed. Typically, your highly available architecture is going to include a third-party load balancer, and we can discuss this more when we get into the deployment scenarios. So the first component I want to cover is Portal for ArcGIS. So Portal for ArcGIS operates as a two-machine site, and it's both active at the web server level, but active-passive at the database level, meaning both machines can take requests, but behind the scenes, there is a primary machine. The role determines the behavior. So if the standby machine is unavailable, there's no interruption. If m2.esri.com goes down, M1 acting as the primary can still serve requests, still has the primary database. So at the client level, the user experience level, there is no real disruption to traffic. If the primary machine goes down, this is simply done by turning off the service, so shutting off the service on primary, or obviously if the machine goes down because of a network issue or disk problem, then the standby is going to be promoted to primary automatically. The time it takes to fail over is going to range, but typically it's between 30 seconds to a minute and a half. So we're looking at the deployment patterns. These are some typical patterns that you may see. On the left-hand side, you have a highly available portal with a load balancer. And the portal machines are reaching a highly available shared content directory. This could be on the file system or in cloud storage. And this approach is simpler. There's less software to configure in the web adapters, but it doesn't support web tier authentication. On the other hand, you can have a highly available portal with load balancers and a web adapter. Again, you need shared content for the portal content, or shared storage for the portal content. And this could be a little bit more complex in that you have to introduce another piece of software and web servers within the architecture. It does support web tier authentication. So in either of these approaches, you're going to have a load balancer within the mix. It's just whether you want to take advantage of WebGIS authentication or not. So next is portal health check. So the portal health check is used to determine whether a machine is available to take requests. And this is a simple request that again only determines whether the machine is available to respond to requests. It's not a comprehensive status check. This is what a load balancer should be using to determine whether it can send traffic to the machines. It's accessed via the portal admin portal administrator directory through the health check API, through the web adapter /portal admin /health check, or through the machine directly over ArcGIS /portal admin /health check. And a thing to keep in mind about health checking the portal machine or even the server machine is that these HTTP health checks are available to give the load balancer a bit of a smarter way to check the health of the machines. For example, you don't want to simply check whether the machine is available. Can the load balancer ping the machine? Because that's not going to give you the full picture of whether that machine can take requests. It's always important to make sure that you're taking advantage of the health check URL within the load balancer's health check. When you're ready to upgrade the highly available portal, keep in mind that even though you have two machines, you still have a single portal, meaning there is going to be some downtime if you're going to do an in-place upgrade. So that being said, it's really important that you are planning for the upgrade, you're practicing the upgrade, and when possible, you take advantage of the read-only mode to minimize downtime once you are ready to upgrade from 10.8 to 10.8.1. I'll go into a bit more information about what read-only mode is later in this presentation. It's important to make a backup. Certainly before you start an upgrade, you might want to make sure that you're creating a backup, whether this is a VM snapshot or using the DR tool. Important that you can roll back to your previous state if the upgrade were to fail. There's no need to know the roles of machines when upgrading to 10.7 or later. Previously, you had to know which one was primary, or even before that, you had to unregister the standby machine or one of the machines from the site before you upgrade. Starting at upgrading to 10.7 and on from there, you don't need to know the roles when upgrading. So that means that the steps to upgrade a standalone portal are essentially nearly identical to a highly available portal, with the exception of installing multiple web adapters if you're using WebGIS authentication. So here's some takeaway points, some key considerations for Portal HA. First, it operates as it only supports two portal machines, so it operates as primary standby. But keep in mind, you can still send requests to both machines. You need to have a highly available load balancer. And if you want to use web tier authentication, make sure that you have two web adapters to support redundancy at the web tier. Take advantage of the health check API, health check resource within Portal. Don't rely on a simple TCP ping type health check from the load balancer. Because we use, Portal is relying on a shared content directory. Make sure that it's highly available. Take advantage of cloud storage when possible if you're in the cloud. When upgrading the portal, downtime and the steps involved are going to be similar to upgrading a standalone portal. The last thing to keep in mind is that all portal machines must be in the same data center. Due to latency and issues in potential issues in communication, Portal, a highly available Portal does not support putting one component in one data center and the other portal in a different data center. For that, we'll talk about geographic redundancy at the end of this presentation. All right, the next component we'll talk about is ArcGIS Server. So ArcGIS Server multi-machine architecture has been around for quite some time. and it operates in a fashion that has no concept of roles. So the second machine you add to the site is no different from the third or the fourth or the fifth. They all have the same roles, which means that there is no interruption when any of the machines are down. Shared config store and server directories paths are required and need to be accessible to all machines. And this could be, cloud storage such as DynamoDB for the config store or highly available file share. Similar to Portal, there's a couple different architectures that you could look into. The first is using simply a third-party load balancer, sending traffic to all the server machines within the site. This, like Portal, doesn't support WebGIS authentication. There are less software requirements in terms of the web servers required to run the web adapter. But again, it won't support WebGIS authentication. You can also configure your architecture, set up your architecture to have a third-party load balancer as well as web adapters. This gives you the ability to support WebGIS authentication for server, but again, there's a need for additional software to support this architecture. In either case, you have a shared directory that is accessible by all machines to store the config store and the server directories. So similar to Portal, Server also has a health check URL, and it's accessible through the REST info endpoint, REST info/health check, through the web adapter or through the machine directly. Again, similar to Portal, it doesn't check, it's not a comprehensive status check. It's simply a request that will determine whether a machine can take requests or not. When you're ready to upgrade a multi-machine site, you would install the software on each machine and continue the upgrade on each machine sequentially. So install the software on machine 1 and run continue upgrade on machine 1, install the software on machine 2 and continue upgrade on machine 2 until all the machines are upgraded within your multi-machine server site. Some takeaway points for ArcGIS Server. First, make sure you have a highly available shared config store and server directories path. You can take advantage of, if you're in the cloud, you can take advantage of cloud native features. Use the health check API within the REST info page to determine the health of the machine in order for the load balancer to know whether it can send traffic to that machine or not. The upgrade process is done sequentially on each machine. So install and upgrade the first machine and then move on from there. Much like Portal, all server machines must be in the same data center. Separating the server machines within a multi-machine server site geographically is not a supported architecture. So when we're bringing it all together within ArcGIS Enterprise, you're likely going to be federating Portal and Server. Now, there's some important URLs and important settings that you need to make sure that you do when you're going through the federation process or even prior to the federation process. So again, you have this public URL, the public portal URL, which is where users are going to use to reach the home app, clients are going to use to connect to the portal. And then you have the services URL. This is the URL that clients are going to use to consume services, to access services. What you also have is this administrative communication. So through the private portal URL, this is the URL that server will use to talk to the portal. And then you have some traffic from portal to server. This is involved in any publishing operations and anything where portal needs to talk to the server through some administrative operations. Those public URLs, portal URL and services URL, they're for client communication, again, for applications and users to use to reach the portal and its services. Internally, the private portal URL and administration URL they facilitate the administrative communication between portal and server and vice versa, between server and portal. Prior to federation, it's important to set the private portal URL within the system properties of the portal. For example, I'll set it to a URL that is highly available, such as through a load balancer. And this ensures that server can talk to portal even when one of the machines are down. So it ensures that that communication between server and portal is traveling through some redundant means. When you're federating portal and server, the administration URL should also be something that goes through a load balancer. And again, this ensures that portal can still talk to the machines in the server site, even if one or more of them are down. So the key considerations are the takeaway points for federation. First, you need to ensure that you have highly available URLs throughout the deployment. This is for the public URLs, the portal URL and the services URL, the URLs that clients will use to reach the resources they need, but also for the internal URLs, private portal URL and the server administrative URL. Oftentimes you'll see these configured against two separate load balancers. For example, one load balancer to handle that the traffic for clients, but then an internal load balancer for the traffic through the private portal URL or the server admin URL, server administrative URL. So the last component that we'll talk about in the realm of ArcGIS Enterprise is the ArcGIS Data Store. So the ArcGIS Data Store highly available architecture is dependent on the type of data store that's registered. And this is more so at 10.8. Prior to this, everything operated in primary standby, but on the left-hand side, you have a highly available relational ArcGIS data store. So in this case, you have primary replicating content to standby. The server site knows which one is primary, which one is standby. If the primary was going to go down, then the server site will know to talk to the standby. Standby is going to be promoted to primary, and it's going to know to talk to that machine. On the other hand, you have highly available tile cache data store at 10.8, and this is operating in a clustered manner instead. So you have two cluster members, and they're replicating content between them. And if one of the cluster members goes down, then server knows to talk to the other cluster member. Prior to 10.8, both relational and tile cache data stores operated in primary standby. ArcGIS Data Store operates a bit differently than Portal when it comes to failovers. For Portal, if the service is stopped on the primary, then the standby will promote itself. But for Data Store, there are internal checks to make sure that failover is really necessary. For example, the computer crashes, it gets unplugged from the network, or there's disk corruption. Failover does not happen immediately if the Data Store service on primary is stopped. So this is an important distinction between Portal and Data Store failovers. When you're ready to upgrade a highly available data store, you'll run the setup on both machines, and much like Portal, there's no need to take note of roles, which is new at 10.7. You run the configure data store operation to upgrade both relational and tile cache data stores. So again, here's the overview of highly available deployments for ArcGIS Enterprise. You have a highly available Portal, which operates primary standby. You may include a web adapter within your architecture plan to support web tier authentication. Multi-machine server sites have been around for a bit, and they can scale horizontally to 3, 4, 5, as many machines as you need to. Both Portal and Server require shared content directory and config store and server directories paths that are accessible by all machines. And finally, the highly available data store operates primary and standby for the relational data store and clustered for the tile cache data store starting at 10.8. when you're ready to upgrade your ArcGIS Enterprise deployment, when it's highly available, very similar to upgrading a standalone deployment, you start with the portal. So you upgrade the portal first, then upgrade the server, and then upgrade the ArcGIS data store. Excuse me. Cloud deployments in the cloud also let you take advantage of native cloud storage options for highly available deployments. So the portal content and the ArcGIS Server config store can both be stored within native cloud storage solutions, such as a S3 bucket or a container within Azure. The Server config store can be stored within DynamoDB or Azure Tables. ArcGIS Spatial Temporal Big Data Store backups, as long as WebGIS DR backups, can also be stored within cloud storage. And there's other workflows that you may want to take advantage of when you're working within cloud deployments, such as storing map service cache tiles within the cloud, supporting geoanalytics data input, and raster analytics from cloud storage. So there's other things that are important to keep in mind that have to be considered when you're developing a highly available deployment within ArcGIS Enterprise. On the data side, your enterprise geodatabase, such as SQL Server, Postgres, and any file-based data has to be highly available. If that service data goes down, then the services that are powering your enterprise and your maps and apps won't be available. On the software side, outside of ArcGIS Enterprise, you have your web server to consider, as well as your load balancer. These need to make sure that they are highly available and they are redundant. You also have to consider hardware, your file server and network, along with people and processes. Making sure that you don't have a single administrator, or making sure that when you need to patch the machines, you don't run the patches on all machines at the same time. You kind of stagger them to make sure that there is always at least one component at each tier, so portal, server, and data store, that are available. It's important that you take advantage of IT governance. You make sure that you are efficient and effective in your use of your IT staff, because you need to make sure that your highly available deployment is operating at all times at an efficient level. Making sure that you're planning for outages, or you're planning for maintenance periods. You're applying patches in a systematic approach. You have correct documentation to know how the architecture is set up. You're testing failover regularly, make sure that things are working correctly, exercising with staff so that everyone is aware of how the software should work. Along all this is monitoring. Monitoring is incredibly important. Taking advantage of something like ArcGIS Monitor to make sure that you're aware and you're on top of whenever there's an issue within your deployment. And it's important to note that being highly available is not a switch. It's not that you're highly available or not. It's it's a spectrum. So making sure that you're taking a look at all the components that are available within your deployment and understanding what's involved in making those components highly available. So as your requirements for being highly available increase, as do the costs. Again, as I mentioned, the cost to support only seconds worth of downtime is far greater than the cost to support a day's worth of downtime. And looking into being highly available is not simple by nature. It's important that you plan correctly, that you practice regularly, because once you are taking advantage of these systems within a highly available, within a mission critical or business critical operation, it's important that things are working correctly. If you are an organization where it's okay if the environment is down for a day, maybe you don't really need to be highly available. On the other hand, if you're supporting again mission critical, business critical operations, you're a 911 call center. You need to make sure that you're available at all times, 24/7. So, being highly available, it may not be a question for you, something that is a requirement. So lastly, we're going to cover disaster recovery. And this is taking advantage of geographic redundancy. So first, we'll cover what is geographic redundancy. So what does it mean to be geographically redundant? We'll talk about using the WebGIS DR tool to achieve a geographic redundancy, and we'll talk about the steps required to achieve it. So being geographically redundant involves managing two separate data centers that are geographically separate, and they're mirrored of each other. So you can have a primary data center on the East Coast and a standby data center on the West Coast. And they're mirrors of each other. If some catastrophic event takes down your primary data center, you can flip over to your standby data center and continue normal operations. So the requirement with geographic redundancy is that you have duplicated configurations in data between the two data centers. This means, you have a full enterprise deployment with all the data necessary to within each environment for the services that have to be served within the deployment. Typically, you're gonna see an organization that takes advantage of geographic redundancy is also going to be highly available within a data center. So not only can they fail over individual components within the data center, but they can also fail over whole data centers if required. The DR tool can be used to move snapshots of data from primary to standby. And this is often one of the more complex disaster recovery options. And this is due to the requirements for the number of machines and architecture, and also making sure that you have a scheduled task that can move backups from primary over to standby at a regular basis. So I'd like to kind of go through a theoretical situation involving geographic redundancy. So let's say I have an environment, and one of the requirements is that the public portal URL and services URL have to be the same between primary and standby. So a traffic manager is directing traffic to my East Coast data center, which is my primary data center. And then I'm using the DR tool to replicate content from my East Coast data center, my primary, to my West Coast data center or my standby. This is happening on a scheduled basis using a Windows Task Scheduler or a cron job on Linux. In the event that my primary data center goes down, the traffic manager can send traffic over to my standby data center. Now, the thing to keep in mind when it's in this state right now is that people can still create content. People can still update content or delete content. So this is an important concept that we'll talk about in a couple slides. So oftentimes an organization has all their users, let's say, on the East Coast, so they'll likely want to get that environment back up and running and then flipped over as soon as possible. Once they do that, then they continue to create backups and then restore them to their standby environment. Cloud deployments, there's some information that is important to make note of. The DR tool does support creating backups from, let's say, an environment in the East Coast region, storing those backups in a different region, let's say a central region, and then restoring them to an environment in the West Coast region. So you can configure your environments so that all the components are in separate regions to make sure that you guard against region-level failures. So what are the high-level steps to achieving geographic redundancy? Well, first, you will duplicate the deployment between primary and standby data centers. This means that you're going to be installing the software, configuring it between primary and standby. Next, you'll create snapshots of the primary data center, and then apply those snapshots to the standby data center. Finally, it's important to monitor both data centers. So this would be making sure that you're keeping track of when components fail within each, making sure that you keep track of whether backups are getting created successfully or not, and obviously getting restored successfully or not. All right, so we're going to go into each of these in a bit more detail. So the first step would be duplication. So making sure that you create duplicate environments between your primary and standby data centers. Our recommendation is that the number and size of the machines are the same between environments, so you don't have any drop in redundancy, performance, or capabilities if in the case that you have to flip over to your standby data center. Now, some organizations may not want to invest in the same amount of hardware for a standby environment. So the DR tool does support taking a backup from an environment that is fully HA and then restoring it to one that is less HA. So maybe single machine sites. As I mentioned in describing the theoretical approach with geographic redundancy, the URLs, the kind of the front end URLs for portal and server for your ArcGIS Enterprise have to be the same. So the entry point into the portal and the entry point for services that are going to be likely used within any maps and apps. And the reason for this is that you want to make sure that in the event that you do have to fail over from primary to standby, that your users don't need to think about what URL they have to use to reach the portal. They can continue to use the same URLs they've always been using to minimize the disruption to their daily responsibilities. It's also important that you have identical paths to data and connections to databases or enterprise geodatabases. This is to ensure that if you do have to flip over to your standby data center, that the services hosted within your ArcGIS server site are able to reach the data that they need to reach. So it's important to kind of highlight what needs to be the same between your primary and standby data centers. Starting at 10.4 with the introduction and 10.4.1 with the introduction of the DR tool, everything had to be the same. This was the public-facing and internal URLs, so the client-facing URLs and the administrative URLs, they had to be the same. By reference data stores, server directory paths, machine names, security information, so all this had to be the same. As we moved on to different releases, and we wanted to make sure that those requirements were lifted to ease in the requirements of deploying or taking advantage of geographic redundancy. So at 10.5, you didn't have the same machine names or internal URLs. In 10.6.1 and on, you didn't have to have the same security information or server-side directory paths. So by security, I mean the domain controller address list or proxy information. So you could have a different proxy server in your standby environment that isn't available, that's different from primary. And we want to make sure that is honored in standby. So next, you'll be creating and applying snapshots. So when you're working in either backup restore or this geographic redundancy approach, it's the same thing when you're creating the backups. They're all done hot, so there's no downtime when creating them. And they can all be automated using Window Task Schedule or cron job. And the full backup is an initial snapshot of all the data within your ArcGIS Enterprise, including any federated server. Internally, it's going to define a base time that's going to be used for an incremental snapshot. So an incremental snapshot is all of the data that has been created or modified, and a reference to what data has been deleted since the last full backup. And the idea behind an incremental snapshot is that it's going to decrease the time it takes to synchronize content, services, and data between the two environments. So typically, you're going to have a schedule that is going to to assist you in managing when these backups are created and when they're applied. So for example, I have a full backup that's created on Sunday. As I go through the week, I'm creating incremental backups. Now as I continue on throughout the week, you can tell that the size of the incremental backups is going to increase, and soon it's going to be counterproductive to continue to create incremental backups. So once the full backup is created again, that'll reset the size of the incremental backup. So it's important to keep track and be aware of how long it takes to create your backups, how much content is created in between incremental backups, so that you can correctly schedule your backups within for your ArcGIS Enterprise. So finally, it's important to monitor and keep track of the health of each environment. So first, validation on your primary deployment that you are creating backups successfully. Obviously, taking advantage of ArcGIS Monitor and any other monitoring utilities to ensure that you're detecting whether there's any component level failures. When you're restoring to your standby deployment, there's of course a bit more information that would give you a good picture of whether the standby is healthy, has been restored correctly, and can be promoted to primary whenever need be. This would be checking to make sure that the index within Portal is in sync, validating any federated servers, validating data stores using the Server Admin API, and checking, even checking any important services or applications. This can all be done using any scripting language that can make HTTP requests, and can be run upon a successful completion of a restore. So it can be run as an automated task within your standby deployment. So it's also important that you make sure that you're detecting component level failures between both data centers, both environments, using the health check URL. If you aren't monitoring the health of the Portal machines and one of the machines goes down, but you aren't notified that, then you're in a situation where you have a single point of failure in that remaining machine. So it's important that you're being notified of when machines fail so you can take action. So I mentioned that there's a potential data difference that you'll have to deal with if you're taking advantage of geographic redundancy. So say that your primary had gone down and your traffic manager is now directing traffic to your standby data center. So in this case, once you flip back over to primary, you may lose that data unless you're asking your users to recreate that content in the primary data center. That data may be lost when you flip back over. So what can you do to prevent this? Again, let's kind of take a look at that theoretical situation. So you have your traffic manager sending traffic to your East Coast data center. You're using the DR tool to replicate content between primary and standby. Your primary data center goes down, so you flip over to standby. At this point now, you have people creating content, you have people updating content, and you may want to prevent that, right? You want to freeze the standby environment, the content within your standby environment at a point in time until you can get the primary environment back up and running. So new at 10.8, we've introduced read-only mode. So what read-only mode does is it freezes the data within ArcGIS Enterprise at a point in time. This is handled within the Portal Administrator directory, so it's initiated from Portal, and it will turn Portal and Server and also disable any editing for hosted services from the Portal. Again, this will restrict any operations that modify site data or configurations, but content is still accessible. So content can't be edited or modified or deleted, but content can still be accessed. So you can pull up your applications and serve out any services and run any operations against services that don't modify data, just as you normally would. But any new data or any existing data can't be modified. Any existing data also can't be deleted. New at 10.8, you can take advantage of access notices and banners to make sure that users are aware of the state of the enterprise. So how would this look now? Well, as soon as you have to flip over to standby, you can turn your standby environment to read-only mode. This again prevents any data from being created, but still lets people access existing data. The standby can remain in read-only mode until your primary environment is fixed, so it's up and ready and it's accessible. Then you can flip back over and continue taking backups from primary and restoring them to standby. So here's some takeaway points specific to geographic redundancy. So first, it's important to understand the requirements of being geographically redundant as your disaster recovery plan. This is, significantly more significantly more difficult and complex than other disaster recovery options, due to the requirements for replication at the file server level, database level, geodatabase level, along with ArcGIS Enterprise components. It's important to understand and be familiar with the ArcGIS Enterprise, including understanding the different components and how they communicate with each other, their relationships. It's important to be familiar with monitoring tools. You need to ensure that you can keep track of when components failed within a data center, using something like ArcGIS Monitor, which is then going to give the indication or give you the knowledge to know whether you have to fail over to a separate data center or not. It's important to run through drills for DR, for disaster recovery, geographic redundancy. Make sure that if you have to, you can practice flipping over to standby, continuing normal business operations, and then flip back over. Obviously, you have to think about how to deal with data differencing, but it's important that you are practicing your disaster recovery plan. If you're at 10.8, take advantage of read-only mode to deal with that data difference, making sure that you're freezing the ArcGIS Enterprise deployment at a specific point in time. And use the DR tool. So use the disaster recovery tool to move snapshots between primary and standby. The DR tool can support different machine names and different kind of internal properties for the internal traffic between the machines. So it's good to kind of look into the DR tool as your mechanism for replicating data and content. Again, as I mentioned, geographic redundancy is definitely a more complex disaster recovery option. So it's important to think about whether it's right for you and your organization, and how much energy and investment you can put into this type of disaster recovery option. Finally, what's kind of important to indicate is that, given all these different approaches, something that should be considered is whether you should take advantage of software as a service or not. There are obviously some benefits and some downsides to taking advantage of ArcGIS Online. First, you have a guaranteed uptime, no cost for infrastructure in terms of managing your own machines and their uptime. There's built-in health checks within ArcGIS Enterprise, ArcGIS Online. But obviously, these, you get significantly more, you get some more functionality out of ArcGIS Enterprise on premises, along with, differences in the authentication tiers, and obviously, making sure that or keep in mind that there are obviously some restrictions to where you can store data. So this will push you kind of towards ArcGIS Online or a SaaS offering versus ArcGIS Enterprise. So thank you very much. I hope this was enlightening. And if there's any questions, feel free to post on GeoNet or in the comments. Thank you very much.